Hi students, this is Karthik Trivedi and you are watching a lecture series of engineering graphics and design with me. So in last video we have seen a basic concepts of projection of point, but that is the only some portions. So remaining portions we are going to cover in this video. So let us start this video. So before we jump onto this video, let us revise what we have seen in the previous video. So in the last video, first we have seen the definition of point. So we know that the point is nothing but it shows exact positions or location on a plane surface. And also we have defined what is plane surface. So we know that plane surface is a 2D object having negligible thickness. And in last video we have also seen that the different types of plane. We have seen principal plane, which is vertical plane, horizontal plane, and then in that video we have also seen that the auxiliary planes. So we have seen auxiliary vertical plane, we have seen auxiliary inclined plane, we have seen a profile plane. So in auxiliary vertical plane we have seen that there is a, you can see that yellow plane in this on the screen over here, that shows the auxiliary vertical plane which is at some angle or which is making some angle with vertical plane, and that angle is phi. Okay, so that we have already seen that in last video. And also we have seen the auxiliary inclined plane. So you can see this yellow plane in this figure over here. Yes, it is inclined to what? It is inclined to HP and perpendicular to VP. So it is inclined to HP by angle theta over here. Okay, so this is not auxiliary inclined plane. And then we have also seen that the profile plane. So you can see this yellow plane over here which is perpendicular to both HP and VP. So that is known as profile plane. After that we have seen in the last video the rotation of HP and PP. PP means profile plane. So we have seen that we give a 90-degree clockwise rotation to the horizontal plane, and we have also seen that we give a 90-degree anti-clockwise rotation to the profile plane. So that we have already seen in the last video. So this is just a quick recap of what we have already done in last video. Okay, after that we have seen the different quadrant system. Okay, so we have seen the first quadrant, second quadrant, third quadrant, and fourth quadrant. And then we have seen in the last video that if we are going to see this figure from the left hand side, it is going to be a look like this. Okay, so then after that we have taken the observer. From then after that we have taken the different point in first quadrant, second quadrant, third quadrant, and fourth quadrant. And in that video we have also seen that if we take the point in first quadrant, its position will be above HP in front of VP. If we take the point in second quadrant, its position with respect to observer. So observer is in the green arrow direction. So observer is at green arrow and he is looking the whole thing from there. Okay, so if we see the position of a point in second quadrant, it will be above HP behind VP, that we already said. If the point is in third quadrant, it will be a below HP behind VP. If the point is in fourth quadrant, it will be a below HP in front of VP. So far in last video we have seen this kind of thing over here. Now in this video we are going to start from here. And also we have seen the notation in last video that if it is a top view we will write a small alphabet letter without dash. If it is front view we will write a small alphabet letter with dash, and if it is side view we will write a small alphabet letter with double dash. Now in this video we gonna see the positioning of the different point in different quadrant. So now let's see the first quadrant over here. Look at the figure which shows the first quadrant over here, right? Now let us imagine a point in a first quadrant. Okay, so this is a point in first quadrant. So let's say this point is point A. Now let us take the projection. So you can see the observer direction. So you see the green arrow, it shows the observer's directions. So from there you're going to take a projection of point A on VP and on HP. So to take the projection on VP you have to look at it from the front side of the observer. So it will be look like this. Yes, you can see the arrow which shows the projection of the point A on VP, and it is going to be mentioned by A dash. Why? Because it is front view, that we have already seen in the notation. Now to get the top view we have to take this projection of point A on HP, because we know that we get the top view on HP. So let us take the projection of point A on HP. So yes, like this. So it shows the projection of point A on HP, but we know that we have to rotate a horizontal plane in 90-degree clockwise direction. So ultimately the projection on HP will be look like this. So this is the projection on HP, this is top view. Again I'm going to repeat. You can see that yes, this is point A. Now we're going to take a top view. So we take projection on HP. So this is the point, this is a top view. But we have to rotate this plane because this top view is on HP. But we know that we have to rotate a HP in any quadrant system. You have to rotate a HP by 90-degree clockwise direction. Why we are doing this? We are doing this because so that VP and HP both come in one single plane, so that it is easy to draw on a drawing sheet. That's why we will give in any quadrant, we will give a rotation of HP by 90-degree clockwise. So let us give a rotation of HP in 90-degree clockwise. So yes, it will be look like this. So here the top view will come and it will be a. So you can see that A dash and A both are now in one single plane. Okay, so this is how we gonna do this. Now let us take the same thing in second quadrant. So let us see the second quadrant. Yes, this is second quadrant, HPVP. Now let us imagine a point in second quadrant. Yes, this is observer's direction. Observer direction is always fixed for all the quadrants. So this is the point in second quadrant. Let us take its front view on VP. So this is his front view on VP. So it will notation will be A dash. Now let's say it's take top view. So you know that top view is on HP. So let us take its top view. So yes, like this. But this is the top view. But you know that we have to rotate a horizontal plane in 90-degree clockwise. So let us rotate this HP 90-degree clockwise. So the top view will be look like this. Yeah, so this will be a top view. This is the point A. Now you can see that both front view A dash and top view A both are in single plane. Okay. Now let us imagine point in third quadrant. So now this is the third quadrant over here. This is observer. You know that observer's direction is always fixed for all quadrant. Now let us imagine one point in third quadrant. So this is the point. This is point A. Now let us take its front view and top view. Or let us take its projection on VP. Yeah. So this will be a dash. Now let us take its top view or let us take its projection on HP. So yes, like this. So it will be over here. But you have to rotate a horizontal plane in a 90-degree clockwise direction. So it will be automatically come over here and it will be a point A. Now A and A dash both are in a single plane. So that is the reason of rotating HP by 90-degree clockwise, so that you can draw both the projection in a single drawing paper. That is the purpose. Now let us take another point in fourth quadrant. So this is a fourth quadrant. Let us take point in fourth quadrant. Yeah, so this is the point. This is point A, which is in fourth quadrant. Now let us take its projection on VP. So it will be a dash. Now let us take its projection on HP. Yeah, something like that. So it will be its projection on HP, but we have to rotate the HP in a 90-degree clockwise direction. So its top view we gonna be look like over here. Yes, this will be the point A. So it will be its top view. So now in the all four quadrant system, you have noticed two things, that a vertical plane is always remain fixed. Second thing, observer's direction is always remain fixed. The only thing that rotate is rotate a horizontal plane, and it is going to rotate by a 90-degree clockwise direction. So this is the different point in different quadrant system. Now let us write some summary over there. Let us write, now look at the first quadrant. Let us assign XY. So this is XY line. So now can you tell me the position of A dash and A with reference to XY line? So A dash is, you know that front view, and A, small a, alpha beta small letter, it is top view. So can you tell me the position of front view and top view in first quadrant with respect to XY? Yes, you can see that the front view is above XY line, which is A dash, and top view, which is small letter a, which is below XY line. So in first quadrant, front view is above XY line and top view is below XY line. Same way, let us assign in second quadrant. Let us assign XY. Okay. Now can you tell me the position of front view, which is A dash, and position of top view, which is small letter a, with reference to XY line? Yes, now you can see that, sir, front view and top view, front view A dash and top view of small letter a, both are above XY line. So in second quadrant, front view and top view both are above XY line. Now let us see the third quadrant. Now can you tell me the position of front view A dash and top view A with reference to XY line. So now you can see that sir, A dash is below XY line. So front view is below XY line and small letter A, which is top view above XY line. So front view is below XY line and top view is above XY line. Now let's see the fourth quadrant. Can you tell me the position of front view and top view? So now you can tell me easily that sir, in fourth quadrant front view and top view both are below XY line. So now you can easily see that the second quadrant and fourth quadrant both are opposite to each other. In second quadrant front view and top view is above XY line, whereas in fourth quadrant front view and top view below XY line. Same way first quadrant and third quadrant both are opposite to each other. So if you remember this slide very carefully, you can solve any example of projection of points. Just repeat this video from till here so that you can solve any example. Now let us see some basic things. So you can see that this is the some point A. So let us take some point A over here. This is observer direction. So you can see that point A is above HP in front of VP. So it is in first quadrant. So its projection is going to be like that. So it is front view which is on VP. Now it is top view which is going to be on HP like this. It is A. And if we draw this thing in a drawing paper, so it is going to be exactly look like this second figure. So A dash and A both are on the same plane. So this is how we gonna show this projection in our drawing book. Let us take another thing. Let us take a point over here. Can you tell me the position of point A? Yes, this point A is above HP but in VP. You can see that the point A is in VP. So if the point A is in VP, so front view will be automatically become that point itself. And what is its top view? So its top view is going to be on XY line. So just look at this figure very carefully. Yes. Okay, so top view, you can see that top view is on XY line and front view is its point itself because that point is in VP itself. That's why. So if you draw this thing over in our drawing book, it will be look like this. Okay. Now let's take another figure. Let's say this point. Can you tell me the position of this point? Yes, this point is in HP and in front of VP. So if we take the front view of this point, it will be on XY line. So projections, you can see that front view which is on XY line. And what is the top view? Because it is in HP, the top view will be at that point itself. So if we draw this whole thing in drawing book, it will be look like this. So now you can easily understand. Okay. Now let's see some basic thing over here. So first angle projection. So what is first angle projections? So if any point is in first quadrant, or if you assume any object in first quadrant, then that projection is known as first angle projection. Let's see this object over here. Let us assume this object in first quadrant. So its front view gonna be look like this on vertical plane. Its top view gonna be look like this on horizontal plane. And its side view gonna be look like this on profile plane. So you can see that front view, you can see the left side figure, the front view, top view and left hand side view, the position of this different plane with reference to XY. So this is just for your knowledge. Okay, so this is we are going to see in very detail in orthographic projections. Let's take another slide over here. This is third angle of projection. So now you can easily tell me, sir, if any object or a point is in third quadrant, then that projection is known as third angle projection method. So let us assume this object over here in a third quadrant. So horizontal plane over here and vertical plane. So in horizontal plane you will get top view. And now in vertical plane you will get front view, but it is going to be a back direction like this. And now we are going to get a side view in a profile plane. Okay, so this is going to be look like this. So now this is the whole system is going to be look like this. So you can see the second figure, the XY line. You can see the position of top view, front view and left hand side view over here. So you can clearly see that the first angle and third angle both are opposite to each other. So in short, if any object is in first quadrant, then that projection method is known as first angle projection method, and if any point or object is in third quadrant, then that projection method is known as third angle projection method. Now quickly revise this whole video, and after that, if you're done with this thing, write down all those points that I have mentioned over here in this video. And now in next video we are going to solve a problem on the projection of point. So I hope you will like this video. Have a nice day. Bye bye.